The Advanced Human Eye Model for ASAP is the first customizable binocular eye model in which users have full control over a comprehensive list of settings and options. Any target may be projected into the eye model. In this case, an eye chart is imaged by an eye with aberrations and correction applied to it. Disease states such as cataracts may be modeled with settings for particle size and density within the crystalline lens. An intraocular lens implant may be modeled as part of an eye with an iridectomy. Lit appearance shows ghost images of the IOL and its haptics. Corneal aberrations may be modeled with Zernike coefficients and observed with many metrics, including a through focus point spread function. The gradient index properties of the crystalline lens may also be modeled with predefined or custom grain profile settings that take into account age and accommodation. An implant, such as a retinal prothesis or bionic retina, may be inserted into an eye model. In this case, a corrective lens improves image quality on the prothesis. In addition to spectacle lenses, contact lenses may also be modeled. Here we see a contact lens applied to an aberrated eye. And what we can do for one eye, we can also do for two. All of the eye model settings and options may be applied to a pair of eyes observing a single target. If desired, a binocular eye model may even be comprised of two completely independent models based on different physical characteristics. Finally, we should note that ASAP optimization routines may be applied to optimize visual systems, including the eye models such as these. The Realistic Skin Model and Tissue Generator for ASAP is the first customizable skin and tissue modeling system in which users have full control over a comprehensive list of settings and options. By characterizing light-absorbing molecules such as eumelanin, pheomelanin, hemoglobin, bilirubin, beta-carotene, and water, the Realistic Skin Model takes optical software into new application areas. One may even model physiological conditions such as anemia, jaundice, dehydration, and many others. The Realistic Skin Model allows models to be created from visual characteristics, chromophore concentrations, or direct entry of measured data. Skin layers such as the stratum corneum, epidermis, dermis, and hypodermis are treated individually and may be included or omitted from models. Additional modeling capabilities include options for simulating hair and capillaries found in skin, and additional trace and analysis options allow users to perform end-to-end system setup and analysis using only dialog windows. No scripting required. Options for modeling blood vessels and energy deposition are also included and are central to current light-based cosmetic therapies and emerging cancer treatments such as photodynamic therapies. To simulate fluorescence, the optical properties of fluorophores may be modeled and fluorescing bodies may be embedded within tissue models. The resulting system output may help quantify the efficiency of devices such as fluorescence microscopes. And what we can do for human skin, we can do for any tissue type within the body. A tissue generator allows tissue phantoms to be modeled from known optical properties available in the literature. A straightforward dialogue-based user interface is used and the resulting tissue model is automatically saved. Finally, ASAP can handle a broad range of biogeometry types, including medical imaging data of organs such as the bladder, brain, and lungs, surgical implants such as stents, and entire optical devices designed to act on or observe biological samples. Combine this with scan and tissue modeling capabilities and you have a powerful tool for research and device development that can help maximize efficiency and minimize development costs and time to market. If you're looking for the most advanced toolkit, please contact us to learn more about the Advanced Human Eye Model and the Realistic Skin Model and Tissue Generator for ASAP.